question for Brayton cycle. Start by some theoretical questions. Which is false statement about multi-stage compression?
Where is the question?
Presentation. The presentation you cannot give.
Your answer?
Sir, could you please share this one?
Not
presentation is not shared.
Sorry.
Thank you.
Yes, start sharing now.
Yes.
A.
A. All agree?
B, I think efficiency will be higher in multi-stage compression.
Yes, the
False
statement
false
about
statement.
stage is volumetric efficiency is high. In multi-stage compressor, isothermal compression is achieved by
employing intercoolers.
Employing intercoolers. All agree?
Yes.
Multi-stage compressor, isothermal compression is achieved by running compressor at very slow speed.
Is it? Huh?
Okay, why we use multi-stage compressor? You remember at the end of the session when I describe Brayton cycle, I tell you the constant pressure. It is close together from the left side and going to be far from the right side, correct? Remember? I think you don't remember. You remember?
What is that?
This compression and this expansion by turbine. This constant pressure with this constant pressure. But in the left side, when going in the left side for TS diagram, we will see this line is close together, and when going right, we will see this line is far together.
Yes.
Remember this or no?
Yes.
Yeah.
Yes, sir.
According to that, this is the reason for to use it multi-stage compression. To don't go up direct. We use multi-stage to decrease the compression of compressor used. So instead of going direct from this line to this line, no, I divide it like this. I go here and go to cooling, and then going again to compress, then cooling, then compress, then cooling, then compress, up to reach to the final stage of the pressure required. So instead of going direct from this point to this point, it's better to make it like stages like this. The total amount of the work consumed for the multi-stage compression is less than from the compressor direct from 1 to 2 by one stage. See with me this diagram in details here. If you're going direct from B1 to B2, this final stage, this first stage or initial stage, this first stage, this last stage. If you're going direct like this, it takes more power. But if you're going to divide this one in stages, you'll see at the end the total power consumed is less. So if you're going to the first stage and going to intercooler, then second stage to going to intercooler, and then going to third stage, you will see the total amount of the compression here is less than the total if you're going by one stage. It's clear? So you're going to make work safe. Clear this one?
Yes, sir.
Same here to present how many work saved here.
But sir, in question, you mentioned that the second number question.
What's the problem for second question?
Yeah, in that multi-stage compressor is used for yes, running at slow speed. Or
Yeah. This is for isothermal compression. Actually, what we will do in practice, not this, because actually in practice we can't do move in or running in low speed. But theoretically, yes, this is the way. But actually, in practice, we can't do that. We make another things. We will see one question related for that.
okay. So answer is that slow running is the answer,
Yes,
right?
yes. Adiabatic compression is one.
No heat leaves or enters the compressor. Bravo B.
All agree? All agree for that? Hello, engineer. All agree?
Yes.
Capacity of a compressor is 5 meter cube per minute. Refer to
Three area.
free area. Yes. Overall, isothermal efficiency of compressor is defined as the ratio of
Delta.
Let's see.
A.
C.
C power to drive. No, I don't think so. Isothermal efficiency is isothermal horsepower to brake horsepower. Okay.
Okay.
Most efficient method for compressing air is to compress it
Isothermally.
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 Correct. Here you can check with me. If you press isothermally, this is the minimum work consumed for this one, which is PV equal constant. It means at index number equal to 1. I think we have one question before we solved it. N equal to 1, this to obtain minimum work consumed. Okay, so PV equal constant. PV to power gamma, which is adiabatic process, this is the maximum we can obtain, maximum, not minimum. PV to power n, which is polytropic, this is in between. Okay.
So means when expansion, then we'll get the maximum work in PV raised to gamma is adiabatic.
Adiabatic is maximum work.
And we will get minimum work in the
Minimum
isothermal.
at gamma or n equal 1. PV to equal constant isothermal process. This is minimum work.
Okay.
Maximum work is done in compressing air when the compression is
Isothermal. A.
isothermal. All agree? All agree?
No.
Yes.
Read again question and give me answer.
No. Minimum work is done.
Adiabatic. B.
This is a poly. Adiabatic.
Adiabatic. All agree? All
Yes.
agree?
Yes.
Yes, correct. Not
No.
isothermal. Please read carefully, okay? This one is isothermal efficiency of compressor. Present here different for ideal process and theoretical or isentropic process or ideal one. This one is theoretical one or isentropic one. If you're going to isentropic, it means the S equal to constant, this isentropic process. So we're going straight like this. And for sure, this, if we talk about for compressor, the isentropic is less than the actual. If we talk for turbine, the for turbine, the isentropic is more than the actual, correct? And depend on the function, because for compressor we need to consume work. So if in ideal case this less, for turbine we need to obtain work. So for ideal is more, correct?
Yes.
For example, for turbine it's going to be like this, isentropic going straight, and other one is going like this. So we'll found isentropic is higher. Clear?
Yeah.
3 to 4, for example. Okay, by the way, the equation is the same. Isentropic efficiency for isothermal efficiency is equal to isentropic work divided by actual work. Isentropic divided by Y actual. Okay? The pressure and temperature condition of air at the section of compressor are
E. E for England.
which one?
E.
Yes, E.
Okay. Pressure is slightly less than atmospheric and temperature slightly more than atmospheric, correct. Isothermal compression efficiency can be attained by running the compressor
At very slow speed.
at very slow speed. Compressor capacity will, with decrease in suction temperature, what happened?
Increases.
Increase. A.
Increases.
Increases. Isothermal compression efficiency, even when running at high speed, can be approached by using
Yeah, A and B.
C. C.
C. A and B.
excellent. Compression efficiency is compared against
B.
Isothermal.
B.
isothermal compression. Airplane employee following type of compressor.
Axial flow.
Radial flow.
Axial flow.
Finished?
None of them.
Actually, axial flow. Intercooling in compressor.
Results in saving of power in
Sir, B.
compressed mechanism.
B results in saving of power.
Saving power.
Yes, sir.
Sure.
Yes, sir.
Intercooling. The reason for intercooler is result in saving of power in compressor. This easy and quick problem. Can you solve it, please?
P1 V1 by T1.
A.
A. All get the same answer?
Yeah. Piezo and this one is Cheso. Double it will be.
No, it's B.
3 meter cube. Just we'll use which one? What will be the
P1.
volume of air if its volume is blah blah in the first stage? So V1 over V2 equal T1 over T2. That's it.
Can you write the formula?
P1 V1 by T1, right?
Yes, I write the formula. Okay.
Yeah.
Yes. One.
One.
Alpha.
1.
Yes.
All agree? No one here? Only one? Yes, when equal n equal to 1. Same curve we presented before. Isothermal compression through most efficient.
D for Delhi.
Which one?
D.
Delta compressor has to run it.
So D.
D.
Because if it runs at low speed,
Yeah,
it will not compress
running
enough.
at low speed because it's about for isothermal compression again. Yes. Ratio of indicated horsepower to brake horsepower.
Isothermal efficiency.
Which efficiency?
Mechanical efficiency.
Mechanical efficiency. not
Mechanical.
isothermal.
Yes, almost right. That's correct. Ratio of work done per cycle to the swept volume in case of compressor is used.
Compression ratio.
Index. Just guessing. E.
Final. Mean effective pressure.
Mean effective.
Here, just brief for what is the swept volume, what is effective swept volume, what is total volume. Actually, this here represents for the total volume available. This is the total here, represent for the total volume available. This one is the swept volume for maximum volume for the cycle and the minimum volume for the cycle. This is swept volume. And actually, for the process itself, this is the effective swept volume. Effective swept volume. Volumetric efficiency. What is the volumetric efficiency? Effective swept volume by swept volume. That's it. This is volumetric efficiency. Effective swept volume to swept volume. And what is clearance ratio? Clearance ratio, it is clearance volume by swept volume. Clearance volume by swept volume. Cylinder clearance in a compressor should be
D.
B.
As small as possible.
As small as possible.
as small as possible. Great. Ratio of compression is this ratio of
Charlie?
spinal.
A.
No, B.
B.
So this is pressure to absolute intake pressure.
Okay.
Here also represent again here this volume of combustion chamber when the bottom reach to top dead center. And this is mentioned for swept volume. This is the area below.
Yeah.
Clearance volume is an actually reciprocating compressor is essential.
E. E for England.
Which one?
E.
E?
E.
Yeah, great, correct. This is not important. Which of the following plants is the smallest and lightest for generating a given amount of power?
Gas turbine plant. E.
Any other idea?
E gas turbine.
Yes,
E.
correct.
Solar.
No, gas turbine is still the smallest one. Simple turbojet engine is basically
Bravo.
Yes. B.
B, sir. B for Bombay gas turbine plant.
yes,
equipped
gas
with a
turbine equipped
propulsive
with
nozzle.
propulsive nozzle and the fuel. This is what we will see next the slide here. Here is some types of the jet engine like turbojet, turbofan, ramjet, scramjet. Just we will describe a small brief for each one. First, I will describe jet engine design. Jet engine design is consists of normal engine, same like gas turbine, like compressor, combustion chamber, and turbine. But here in jet engine, just we add at the beginning diffuser before you going to the compressor, and at the end we put the nozzle before we face the just turbine direct to atmosphere. No, after turbine going to continue to expansion by nozzle. Okay, so the process is the same process for gas turbine, but just we extend the part of diffuser and the part of nozzle. So the process instead of start from 2 to 3 only, now we start from 1, which is referred to the 1 to 2 is diffuser, isentropic compression in diffuser. And continues the same isentropic compression in compressor, 3 to 4 Q added in combustion chamber, constant. Then going to expansion, the same expansion up to 4, which is turbine, isentropic expansion. But here we continue expansion and we get it at 6 isentropic expansion in nozzle. Okay.
Yes, sir.
Here's some free for each one. For ramjet, it has no moving parts. Its compression ratio depends upon forward speed. Has no static thrust. Guided missile. Space vehicle use this type of jet. Also here, I think uses this in high pressure in front of the engine. What else? Accelerated to supersonic. It's working in supersonic. Okay. Scramjet is subscribed from supersonic combustion ramjet. Okay, this supersonic combustion ramjet. So scramjet is working in higher speed more than ramjet. Ramjet, if it's working in a supersonic range, okay, but here this working in supersonic combustion, it means more than ramjet. For scramjet, it's almost in high in what hypersonic speed, not normal like supersonic. That's it only. No, it is hypersonic speed, and this hypersonic speed starting from almost 4-5 Mach number and going to up. Here, if we don't need to talk for this one, just designed by using hydrogen as a fuel and oxygen from atmospheric. Turboprop jet engines. This turboprop will join the shaft of compressor at the end by gearbox and propeller. Here, I think no mention. Just mention for consists of intake, compressor, combustor, turbine, propelling nozzle. That's it. Last one, turbo shaft. Turbo shaft here is variant of jet engine that has been optimized to produce shaft power to drive machinery instead of producing thrust. And this is the shape for this one here, like this. Normally we use this one for helicopter. Okay, some questions is related for this part. It's slightly, some of this question is difficult, but just be aware for the type of the question for this part, not more. For speed above 3,000 km per hour, it is more advantage to use
ramjet engines B.
ramjet engine, correct. Excellent. This mentioned here for ramjet, it is within the range of 2 Mach number to 5 Mach number, and up to more than 5 Mach number, it will be scramjet. Okay. Ramjet engine. No idea?
No ideas.
No problem. For this question, no problem. Is not self-operating at 0 flight speed. Air breathing jet engine. The jet is formed by expanding
Plasma D.
E. Highly heated.
E, sorry.
highly heated atmospheric air. Correct. Aircraft propeller. No idea also?
All of the above.
Yes.
Guessing.
Maximum temperature in a gas turbine is what?
E for England.
700.
700, yes, correct. Work ratio of a gas turbine may be improved by
A and C.
A and C,
A-
increasing turbine work and decreasing compression work.
Eco.
E for elephant.
One more option.
Yeah, eco, sir. A and C.
Decrease the compression work and increase the turbine work. Work ratio of a gas turbine is ratio of
Sir, B. Sorry,
net
C.
work
Turbine and heat supplied.
work done by turbine and the heat supplied. Actually, mainly heat talk about for work ratio. So almost work ratio means almost all work. Network output and work done by turbine. This is schematic for the reheating in gas turbine.
D.
This schematic mentioned for this compressor, this combustion chamber, this turbine. But the turbine, it is going to be stages. You remember steam power plant when I discussed steam power plant and reheat?
Yes, sir.
This almost
Yes.
the same. We're going to the stages of turbine. The first turbine, the output of this one going to reheat it again from the line coming from the combustion. So the temperature is increased again and they're going to continue expansion by the second stage of the turbine. Okay.
Yes, sir.
So in this case, what is the benefits for that?
Delta, sir, both in increase of work ratio
Increase
and
of work ratio, because work ratio it is mainly direct for the net work to the turbine work. So increase work ratio. Only that or another thing?
I don't not sure about decrease in of thermal efficiency.
Not sure. But
Okay.
here it's sure. Increase of work ratio and the decrease of thermal efficiency. The thermal efficiency at all is decreased. Main purpose of reheating in gas turbine is be careful, please, because he mentioned main purpose.
Reduce.
C.
E increases speed, increase pressure ratio.
C.
No, actually the main purpose increase power output. Reheating in multi-stage expansion gas turbine.
Sir, reheating is what? Which was the process, sir? I forgot actually.
Reheat, it means we divide the turbine in stages, and after expansion for first stage of turbine, take this amount of the output and they make a reheat with the output of the combustion chamber to heat up the temperature and
E.
going to second stage for the turbine. So you obtain more
D.
work output from turbine because you increase the temperature again, correct?
So in the same turbine, it is going to the second stage with increased temperature.
Yes.
In the same turbine, not in the other turbine.
No, second stage of the turbine, not not first stage. First is this
Mm.
stages of turbine. First stage, second stage, it's multi-stage.
Yeah, maximum work output, delta. It means
Delta, yes. Compression ratio in a gas turbine is of the order
8 is to
12
1.
is 12, 8 is to 1.
8 is to
8
1.
to 1. 8 to 1.
Mm.
Gas turbine cycle with regenerator. Regenerator is slightly different for reheating. Regenerator, you take the exhaust for the last stage of turbine. Last stage of turbine, the output is exhaust, correct? Normally, this exhaust it is still in high temperature. So instead of lose this energy in nothing, no, take this one, this branch, and connect it to like heat exchanger again. Connected with the make heat exchange, heat transfer between this the exhaust and the output of compressor. The output of the compressor is air, correct? Still, the temperature of the air is low temperature, and going to in combustion chamber to mix with fuel to burn and obtain energy, correct?
Yes.
So before air going to the combustion chamber, just I going to heat exchange this line of the air with the exhaust of the turbine
Okay.
before I lose this exhaust. So what happened? I increase the temperature going to the combustion chamber. So you increase what? The efficiency total for the combustion chamber
Yeah.
and decrease what you
Heat
added.
input. Heat input.
Correct? Yes, you decrease Q added. If you decrease Q added, what happened?
Increase thermal efficiency.
Yes, yeah, same like this. The output here is around 250 to 300. Just going back again here to mix or not mix, just heat exchange between this line for the exhaust and the line coming from the compressor to the combustion chamber. Clear?
Okay. Yes, sir.
The working fluid in air turbine is
B. No.
working fluid in air turbine is mention here air. So it
Air.
is one single phase. One single phase. Specific output per kilogram mass flow rate of a gas turbine having been fixed efficiencies with one turbine and fixed higher and lower temperature with increased in pressure ratio. Well, increase pressure ratio. Remember the curve.
First increase, reach maximum and decrease.
Yeah, going to increase, then maximum, then decrease. This curve you studied before, correct? Back to the slide for this